In this video, I'll demonstrate how to create a plot data table with X values that automatically update based on the calibrator minimum and maximum values. This example uses the same data and general process as outlined in the ELISA data analysis using the MyCurveFit XL add-in video. For more information on calculating curve fit parameters and concentrations, please see that video available at the below link. Briefly, we've already performed the required analysis for ELISA. The blank correction has been performed, the 4PL parameters have been calculated, and our concentration values have also been calculated. Moving to the Fit tab, let's now create our plot data table and corresponding curve chart. The plot data table will be used to create the fit line in our curve chart representing the 4PL fit. Recall from the first ELISA video that the plot data table should be constructed so that the X values span the range of our calibrators. I'll use a formula here to allow me to calculate the X values spanning from the minimum calibrator value in essentially 1% increments. First, we need to calculate the minimum and maximum calibrator values. Because we're using a formula and cell references to calculate these values, they'll automatically be updated if the calibrator values entered on the datasheet are updated. First, I'll enter equals, min, and select the range of cells containing our calibrator X values. Pressing enter returns the minimum value, which in this case is 5. Next, I'll enter equals max, and again select the range of cells containing our calibrator X values. Pressing enter returns 160, which is our maximum calibrator value. I've already populated the increment column of my spreadsheet with values beginning at 0 to 100 at increments of 1. This will give us 101 points to plot our curve line with. If you find that your standard range is quite large and requires more than 101 points to smoothly plot, you can make these increments as small as necessary to create a smooth curve fit line. The formula I'll use to calculate the X values is the minimum standard plus the increment value multiplied by the maximum standard value minus the minimum divided by 100. So for our first data point, I'll enter equals and select the minimum calibrator value. I'll press F4 to add dollar signs to make this an absolute reference, meaning that when I drag down the remainder of the table to automatically fill the formula, this reference will always point to the minimum calibrator value. Next, I'll enter plus and select the increment value. I'll not add the absolute reference here because we want this portion of the formula to update based on the associated increment value. Multiplied by the maximum calibrator value, pressing F4 to denote an absolute reference, minus the minimum calibrator value, again pressing F4, divided by 100. I'll press enter to apply the formula. Now I can drag this formula down the remainder of the column to fill the rest of my X values. And once that's complete, you can see that they span the range of my calibrators from 5 to 160. Next, we need to calculate the Y values corresponding to the X values. To do this, I'll enter equals MyCurveFit, and I'll select the 4PL Calc Y option. I'll select the calculated parameter values, press F4 to denote an absolute reference, select the corresponding X value, and press enter. Now we can drag this formula down to fill the remainder of the column. From here, I'll go ahead and create the curve chart. I'll highlight the X and Y values and select to insert a scatter plot. I'll select to format the data and update the formatting to display a solid, smooth line with no markers. Next, I'll add another data set. This time, I'll select my calibrator X and Y values, and I'll update the format of this data series to show no line and only markers. We can also update the X-axis to a logarithmic scale. For a more detailed walkthrough of how to create your curve chart, please see the below video. Now that we have our plot data table and curve chart created, let's update our calibrator X values. Let's say for my next assay, the calibrators are 400, 200, 100, 50, 25, and 12.5. Notice this is not only a new calibrator set, but also a different type of ELISA, where our first example was a direct ELISA, meaning as the concentration increased, the OD also increased. This ELISA is a competitive ELISA, where as the concentration increases, the OD decreases. We'd expect in this case for the curve to also change directions. Opening the Fit tab, we can see the calibrator minimum and maximum values have been updated. The plot data table begins with the minimum value of 12.5 and follows to the maximum value of 400, and the curve chart has also been automatically updated, with the curve following the new expected direction. Using this method to create your plot data table can help create a widely applicable template for performing multiple different types of ELISAs. You can download a copy of this template from the below link. If you have any questions about how to create a plot data table that automatically updates based on your calibrator values, please email us at support@myassays.com.